Hi, I'm Jason Roth. In the previous videos, we installed SQL Server 2008 and began using SQL Server Management Studio. In this video, I'm going to show you how to write basic database queries in SQL Server 2008. I'm also going to provide some tips and tricks along the way. Let's start by launching SSMS. On the Start menu, expand Microsoft SQL Server 2008 R2, and then click SQL Server Management Studio. Type the name of your SQL Server instance, and then click Connect. In our first video, What is a Relational Database?, we introduced a fictional database that contained experiment data. This database has three tables: experiments, runs, and run values. Recall that relational data is often separated or normalized into distinct but related entities, as we see here. A query is just a question about the data. For example, your manager or professor might ask a simple question, such as, what experiments does this database track? To answer this question, let's create a query. On the toolbar, click the New Query button. In the query editor, type select star from dbo.experiments. The language used here is called Transact SQL, or T SQL for short. The most basic T SQL query has two main parts: the select keyword followed by the requested columns, in this case asterisk indicates all columns, and the from keyword followed by the table that contains the data. The experiments table here is prefaced by DBO, which is the schema that owns the table. This is clearly shown in the tables list in Object Explorer. Now press the Execute button on the toolbar. We get a very common error, invalid object name. I can see the experiments table in Object Explorer, so why is it invalid? In this case, I'm not targeting the correct database. If we look at the toolbar, we can see that this query window is targeting the built-in master database. I'm going to change this to experiment data. Note that you could also accomplish this through one additional line in the query window. Use experiment data. Run the query again, and you now see the results window. It shows that there are 3 experiments in the experiments table. Let's look at a few other things you can do with queries. The where clause allows you to filter results. First, I'll paste a copy of the existing query, and then I'll add the clause where experiment equals exp1. Note that strings use single quotes in T SQL. Run the query. This time there are results from both queries, but the second query returned only one row, where experiment name is equal to exp1. I'd like to point out 2 helpful tips for running queries. First, I find it easier to press F5 to run the queries instead of using the mouse, and I'll do that throughout the rest of this video. Also, if you highlight text in the query window, only that text will run. This is an incredibly useful feature of the query editor. Let's now quickly go through several other query variations. Instead of using the asterisk to specify all columns, you can specify specific columns. You can also use the order by clause to order the results using one or more columns. Specify either DESC for descending order or ASC for ascending order. You can compose new columns from the returned data. For example, here I concatenate the experiment name and the description and name the result derived column. Also note the brackets around the description column. Description is a recognized keyword, so the brackets tell the database engine to treat it as a column name instead. Brackets are also necessary for names with spaces or other special characters. Now we need to introduce 2 more complex query concepts: aggregations and joins. Both of these are best defined with examples. Here are the actual temperature readings from various experiment runs. We can see here that each run can have more than one temperature reading. What if I want the average temperatures for each run? To do that, I need to aggregate the data, which combines the results, based on the run ID. To aggregate the data, we need to use explicit column names. We'll select the run ID, and then use the AVG function to average the values for each run. Finally, we need to add a group by clause to indicate that the results should be grouped by the run ID. So instead of 3 rows with a run ID of 1, there will be 1 row and an average of all values with that run ID. AVG is just one of many aggregate functions. The group by clause and aggregate functions can help you analyze your data in many different ways. Joins are also explained best with an example. Joins can return combined results from multiple tables. This is important in a relational database. For example, here are the results from two separate queries. The first returns the experiments. The second returns the runs. You can see that the runs refer to experiments by the experiment ID column. But what if I want to have a single query that returns runs along with the associated experiment name? In this case, a join is required. We're interested in adding experiment information to the runs query, so let's start by selecting from the runs table. When using joins, you should alias the tables to be able to more easily refer to the columns of each table. In this query, I'll alias the runs table as R, and then prefix the runs column with R period. To add information from the experiments table, I'll use the inner join operator. Note that I first alias the experiments table as E. I then specify that the experiment ID column in the experiments table relates to the experiment ID column in the runs table. The final step is to add the E.experiment column to the column list. When I press F5 to run this query, I see the experiment name is now added to the run results. Obviously, I can't cover all of Transact SQL in several minutes, so I'd like to use the rest of the time to share some learning tips. First, when you're experimenting with increasingly complex queries, construct it one piece at a time. We already started doing this with the join example. Let's do more. I'll add the min aggregate function to determine the minimum start time for each experiment. Run the query to make sure that it worked. And then I'll add an order by clause to sort the results by the minimum start time. Again, run the query to see the effect of that change. Because I test each change, I'm able to more easily and accurately construct a complex query. Now let's say you finish watching this video and completely forget how to write a query. I highly recommend leveraging SSMS to help you both learn and remember Transact SQL. Let me show you one way. In Object Explorer, right-click on the Experiments table. Select Script Table As, click Select To, and then click New Query Editor window. It brings up the basic syntax that you can edit and run. This technique also provides script examples for other types of queries that we didn't have time to cover, such as insert and update statements. My final tip is to point you to the numerous examples in the documentation. Open your favorite search engine and search for Transact-SQL select site:/mstn.microsoft.com. One of the first links should be the Transact SQL documentation for the select statement. A link to examples is at the bottom of the topic. For many people, using Transact SQL examples is the fastest way to learn. More information and resources can be found on http://learningsqlserver.wordpress.com. For example, to create the experiment data database used in this video, you can select the video series link and then click the link Experiment Data Database Script. Copy the script and run it in a new query window in SSMS. This creates the database and adds the data. At that point, you can try all of the queries in this video and experiment with other variations. I hope this has been a helpful introduction to using queries. Look for more videos on Learning SQL Server coming soon. Thanks for watching.